Hello, everyone. Good morning. My name is Joseph Lewis. I'm a faculty at Oregon State University. I'd like to talk about some of the work I've been doing with my students on using VR site visits. So we're calling them VR site visits or VR scenes of operations to enhance remote learning experiences for civil and construction students. So as you know, especially after COVID, we've been seeing a lot of rise in the number of remotely offered construction engineering management programs. So obviously, these offer a lot of flexibility and cost benefits for students, especially folks who are working. But one of the questions that keeps coming up as we are kind of preparing to transition or to introduce these programs is how do we provide lab and experiential learning experiences for these remote students, right? And so as a response, we were kind of exploring the use of very high accessibility mobile phone-based virtual reality site visits as an experiential tool. That's what I'd like to talk about. So what we did was we created these VR scenes, and we had students engage with that, solve a problem using that. And also, in a separate instance, we took them to a real-world site visit. We just wanted to compare the experiences and see if there was some comparison and if the VR could, be a proxy for these site visits, right? So the questions that we wanted to ask is, does it actually enhance student learning experience and engagement? And there was another set of questions about, does it enhance student understanding of some of the concepts that we were teaching in class? So just quickly about the methodology. As I mentioned, we developed a survey that had, several Likert-style questions. So on a scale of 1 to 5, tell us if you agree with this or, disagree with the statement. We had several statements. And we gave them the same survey after taking them to a real-world site visit for a heavy civil project. And we gave them, in the classroom, we gave them this mobile phone-based VR exercise. We asked them the same set of questions. So that and we were able to code them so that we could compare the responses for each student across both experiences. And that gave us some insight into, where we could be doing better with VR. And this is just, obviously there's a lot of text in here. There's some of the questions. So for experience, we are asking them about, did you experience any kind of VR sickness? Did you feel overwhelmed with the VR experience or with the real world site visit experience? For engagement, did it make you feel like engaging with the content? Were you bored during this thing? Why was your attention somewhere else? So we try to get a sense of that. And for understanding, we were really asking them about, concepts like, equipment interacting with each other, what impact that has on the production of the entire operation, idle times of equipment, and so on, right? So now let's just get into, the VR scene development. So for this, we used discrete event simulation-based virtual reality. So as you might know, discrete event simulation allows us to quite accurately model the sequence of operations and the resources that are being used in operations. So you really get a sense for, the physics of the operation as it might happen on the site, right? And we use the outputs of that to visualize it in a game engine, which is Unity. And we were able to publish it on the web so that folks could access it on their mobile phones without any browser. So that really helped with the accessibility portion of it. So we didn't use any specialized VR headsets or apps or anything, right? And for DES, we use this software called Consprobe. And of course, we use Unity for the game engine. And this is just an example of, the discrete event simulation that's running in the background. This is not what the students see, but this is what generates a scene that you'll see. So as you can see, we have excavators interacting with trucks to just do a simple load, haul, dump return here. Of course, we can increase the complexity of these operations as needed. This is what the students would see. And yeah, if you're quick enough, you can just get this QR code and see it on your phone as well. But what you see is, we get this really simple animation of what might be happening on the site, right? And we've color-coded these trucks. So I think one cool thing that we were able to do is it's not just about them seeing this thing and trying to understand what's happening. We actually ask them to look at this thing, at this animation, and actually take cycle times by observing the trucks. So that's why these trucks were color-coded. And so they took cycle times, and then they had to use this to solve a problem. So we asked the students, Imagine you're a project manager and you visit your site, and this is what you see. So based on the cycle times that you're observing, do you think it's possible to move a certain amount of soil in the next 2 days? If not, would you want to add an excavator or add a truck? So we're able to really get them to engage with the content, I think. Another thing that I want to just talk about here is, until now, we've been using textual descriptions of problems. We give them just a question. We tell them what the times are and ask them to calculate productivities. Now, of course, I mean, with ChatGPT, just take a picture of that, you get the answer. At least yet, I don't think we can do that with this. So this could be a cheat-proof way to engage with the students. Okay. We're also having them, we're creating more sophisticated scenes by including BIM into the DES. So now we're getting some product process integration here. So here we're using the BIM model of a modular building, and we're kind of, again, tying it with the discrete event simulation model of the processes that are involved. So we're kind of simulating these cranes and trucks. And again, now you can ask questions about, how much laydown space would you need for this project based on the productivities that you're seeing of the crane, of the trucks, and of all these interactions that you see going on. So we can start to really get some more interesting examples that we share with the students. So just back to the work that we did for the data analysis. So we had students access this in class. The long-term plan is to get them to do it for remote students. We're just rolling out our remote program. But they had to work with this, with the scene, and they had to actually, use their phone as a stopwatch to get the times, and then work together in teams to solve the problem. And coming to results, a lot of information again, but just to show you, when it comes to understanding of concepts, there was a pretty marked improvement in student understanding of various concepts with the VR as opposed to taking them out to the real world. And that may be an unfair comparison, but we think that's because with the VR experiences, you can really be intentional about what we're showing to students, right? We can really make the VR scene reflect the concepts that we're showing. So if you want to show an equipment breaking down, you don't have to hope that an equipment breaks down when you go to the site, right? You can actually make it break down in your simulation, ask them questions about it. On the other hand, with the experience and engagement, the colors are not coming out very clearly, but you can see that, the bars are pretty much, they're not too far off with each other, right? So there was kind of an equivalent experience and engagement that the students felt with a real world site visit. Of course, there's a lot of excitement that you can't generate with VR when you go to the site. It's an actual site, right? You cannot just simulate that. But students really appreciated the convenience of seeing things that they could actually relate to in class. The other thing was, but they did mention that they felt a little overwhelmed with the environment, with the VR thing. And that, I think, is because they actually had to solve a problem. Whereas a site visit is more of an excursion. You get to skip class for a day and go out. They also mentioned that, they didn't know what to expect with the VR. So they were very anxious, I think, about getting the exact times right, getting the exact answer right. So I think there's a lesson in there that, you don't need the exact answer. We just need an average. And you're not going to get the exact answer. It doesn't really matter. So with that, with our conclusions, we were able to show that, these virtual simulations, and this is for a sample size of 46 students in one class. Of course, we want to do it in other classes as well. But it did enhance the outcomes for student understanding of concepts, right? Especially when these learning outcomes are tied to customized simulations. And now, we have all the tools to make these simulations really get to what we want to show them. We're providing a new way of experientially engaging with content in classrooms, which is ChatGPT proof. Okay, so this might be a cool way to test students on things. No need for specialized VR equipment. This works on your phone. I don't know if anyone is able to try it out, and then I also want to just make this last point here, which is that it provides a valuable low-stakes use case for discrete event simulation-based VR. We have these really sophisticated tools for generating simulations and visualizations. It's not really adopted by the industry, but I think this is a way that we can easily do that in the classroom. So with that, I'd like to end and